Hi guys, I'm Technivorous. I am big on 3D printing. As you can see, this is my 3D printing channel. There is a lot of info here. And if you're just getting into 3D printing, you're curious about how to get into 3D printing or what the process entails, or you just got a new 3D printer and you'd like to know how to use it, basically this video is for you. So, you just got a new 3D printer and you'd like to get it fired up and print some models. Well, we're going to go over the whole process, front to back. And as you can see here, this is my printer. Well, one of them. You can see a couple behind me. This is the TiVo Tarantula Pro. The one next to it is a Creality Ender 3 Pro, and they're both very nice printers, both around $200 budget machines that put out very good quality models. Now, the process itself is not that complicated. It might seem like a few steps, but once you get it dialed in, it's pretty easy to find the model you want, slice it, transfer it over to your printer, and get it printed. The first step in this process is obviously procuring or making a model. So we are going to go ahead and let's just take a look at the printer here real quick. And as you can see, it is going back and forth. The bed is moving front to back. And then this bar that the X gantry sits on here going across will raise up and down, and that is your Z-axis. So 3 directions of motion, actually 6, because it goes both ways in most directions. The build volume, that is what they refer to as the size of what your printer is capable of printing. Both of these ones will print 230 millimeters wide by 230 millimeters deep, which is about 9 inches, and they go about 250 millimeters high. But first, before you can print a model, you have to either find a model or make a model. So before you can start printing, you're going to need a model to print, and there are several places online where you can procure pre-made, ready-to-go models, and I will show you that in a few minutes. But for now, I want to show you a couple of programs that are free to use to make your own model. And the first of those is going to be Blender. Blender is 3D animation software. It can be used to make any model that you choose. It's got a very good sculpting engine, so you can go ahead and just kind of brush and sculpt the object that you want from primitive objects. I'm going to open something that I sculpted here, and we'll just take a look at it. Now, this is for a game, and as you can see, it is untextured. It's still in the sculpture texture here. The material is just kind of plain, but this could easily be 3D printed, and the way that I would 3D print a model from Blender would be to go to File, and then Export, and then STL. I can then save it under whatever name I want in whatever folder I want, and then retrieve it later in my slicer. I'm not going to save this one. I have plenty of STLs we can import when we get to the slicing stage. But remember that STL is your main file type for 3D printing. The next step of the process is slicing, and a slicer will take the STL and turn it into something called G-code, which is what your printer actually reads and will tell your printer what to print. Other free programs for making models. This is tinkercad.com. This is an online app. It works really well for a CAD program. Doesn't really have a sculpt function, so it's hard to make organic looking creations in Tinkercad. But anything that is mechanical or has to have fitting parts or part accuracy, this is a great little program for it, and it is a great place to start. If you try Tinkercad and you decide that you like this CAD program and you want to go in more of a CAD direction instead of a sculpting direction, a couple other programs I can recommend are Fusion 360, which you can get a free license for as long as you're not using it commercially. That also needs an online connection to work, but it works amazingly. Or you have SolidWorks. SolidWorks is not free. You do have to pay for it, but it does run offline, and it is also a very strong piece of software. And on the other hand, we have pre-made models that you can download. Now, this is definitely not the only site, and it crashes a lot. There are a lot of complaints about this site, but it is one of the largest repositories of 3D models, and I can tell you for me, it works 95% of the time. I haven't really had any issues with it. It is probably the most recommended model repository at the moment, although there are a few that are gaining popularity, and hopefully we'll pass it up this year. But this is Thingiverse.com. There are a ton of different categories, and you can just type something in. You can find pretty much anything you want to search for up here. And then you will go in and download those models. And when you download it, it will come with the zipped up file that has your model in it, and it will come with the STL file zipped in that file. Usually there is a README file as well that will tell you what parameters to set in your slicer to get an accurate print, such as layer height and whether or not you should use support. So I do have a couple things downloaded from Thingiverse, and this is the route that we're going to go because it does have that README file, and I'm going to explain that to you as we walk through the slicer. But first, let's go over a couple of slicer options because there are quite a few, and some of them stand out more than others. The first one I want to show you is going to be my personal favorite. This one doesn't get used as much as two of the others I will show you in a little bit, but it is an awesome slicer. All of these slicers are free, by the way. So this is Matter Control. This is my favorite. I like it a lot. It works really well. It has this Tinkercad-like building interface in it where you can also build models right in here. So it's a great place to start. Unfortunately, there are more popular slicers and therefore easier to use and better supported slicers. So we will check out a couple of those. If you have a Creality machine, checking out the Creality slicer is definitely worth a look. But I will tell you that this slicer is basically a reskinned version of this slicer. Now this is Kira. This is probably one of the two most popular slicers that you can get. It works very well. They're constantly updating it, although when they put out updates, they do tend to have a couple bugs in them, which they fix in the next update. So it's kind of good that they roll through updates pretty quickly. But you can see it looks fairly similar to the Creality slicer. The only difference being the Creality slicer is built on an older version of this Kira engine. So we'll get back to Kira in just a second because this is the slicer we're going to be using. But I wanted to show you the other most popular slicer, and that is Prusa slicer. This one is a very nice slicer as well. It is made specifically for Prusa printers, but you can use it with pretty much any FDM machine. And the people that use this swear by it. I have used it a couple times. I've had some pretty good luck. There were some things I didn't like about it. I keep it around because I like to keep things updated and review new features, but it is not my go-to slicer. This is the one that came with my newest printer, the Tevo Tarantula Pro. It's technically not a slicer, just a printing interface with slicing interfaces built in. The interesting thing about this is if I go in here and click slicer, you see here it says slice with Kira engine. Well, there are other slicers in here that are available. Now, these are all slicers that are installed on my computer. So I can slice with Kira, or Slicer Prusa Edition. Now the reason there's two of these is because this slicer I showed you is actually a different version of a slicer that's just called Slicer. They branched off. They've basically made their own development of it. They have their own version that they update, and it is different now, but it is based on that same slicer engine. Those three being the main three engines that run pretty much all the slicers. There's really no point in using a slicer like Creality slicer, as it's basically a port of Kira and doesn't have all of the stuff that Kira has, so we can close that. Repeat ear is nice as well if you want to try slicing with the Kira engine or the Prusa engine and compare the models, but this one also, it's kind of pointless because in here you don't have nearly the amount of settings that you have if you were to just use either Kira or Prusa slicer. So we're going to get more functionality by using one or the other. Although I will say, the one thing I like the most about this is the manual controls. You can go in here, and most slicers have this, but I just like the way this one's set up, because in Kira, if you send a G-code command, you don't get a return. But here you'll get a return. It'll show up down here. So we can close that as well. And we're not going to be using Prusa slicer either, so we'll close that. I'm going to bring Matter Control up one more time to close, just so I'm not running 20 different slicers. We are going to be using Kira here. And I have one more free software I want to show you while we were talking about connecting to the printer. This is Pronterface. This program connects directly to your printer, just like the other ones do. But it is a really robust program for sending commands to and from your printer. We'll get into this more in depth later. You don't need to send commands to your printer in most cases, but it's something you use for adjusting settings in the firmware and things like that when you get into more advanced use. The other thing is this slicer here. There is an actual slicer. I can pull a model in, and if I go to slice it, it will open Slicer, not Prusa Slicer, the original slicer, the latest version of it. So it's kind of like Prusa Slicer, but a different branch. Anyway, that's a lot to throw at you. The reason we're coming back to Kira is because, like I said, Kira is probably the most popular slicer. It is one of the simplest to use. It is the most often updated and has a very good community support system, as well as a lot of online resources for how to use it. In fact, if you go to my channel page and type in Kira in the search box, you will find a ton of videos basically covering all the versions since version 3.4 and telling you what the new features are, as well as a couple of tutorials and how-to videos. So feel free to pop over there and check that out. But for now, we're going to move on and show you how to import your first model. And there we go. It's kind of nice. You can just drag and drop. So your screen should look something like this. If you don't have Kira set up yet, I do have a tutorial on how to set it up. Go ahead and check that out and come back to finish this video. But if you're just watching this as far as seeing whether or not you want to get into 3D printing, don't let me overcomplicate things. This is a lot simpler than it looks. I basically just drag and drop. As you can see, it's got this red spot here. That's going to want support. So I would click the support button. You can see I have a few of my settings set here. And I'm actually going to go into my custom settings and do a little moving of things around. I know I had been printing at a different temperature and I want to change that. There we go. We're going to do 220. And we're going to change the adhesion as well. If you're not familiar with adhesion, like I said, it's in that Kira video for how to set up Kira. We'll worry about that another time, but we are going to be using the brim. And now we can go ahead and hit slice. Now the program is going to take care of all the hard work of going through and basically making a connect the dot map of the individual layers of this model. That's why it's called slicing. It's going to slice it into flat sheets, and then it's going to make the machine code to tell the printer where to connect those dots in each layer. Then it'll raise up to the next layer and put down that layer in a connection of dots, and basically it builds the model in this way. This is called fused deposition modeling, and it's basically depositing and fusing those deposits into a model. That's where it gets its name. So slicing is taking a little bit longer than it normally does. This is a decent sized model, so we're not going to rush it. Basically, once you have this part of the process complete, you are able to save your file, and it is no longer going to be an STL file. It is going to be a G-code file. That G-code file can either be sent directly from your slicer to the printer, or it can be stored on an SD or micro SD card, depending on which printer you have, and inserted into the slot on the printer. Once you've inserted the card, we can select that model and print it from the printer, and I will show you how to do that just as soon as we get done slicing here. And now that I've got my model all sliced up here, I'm going to save it to file, but let's go ahead and check out the preview mode. This is basically going to show you now, if I go all the way down to the bottom, it's going to show you this is the first layer, okay? Now the first layer is basically your most important layer. If this adheres to the bed and goes down well, you're going to have a decent print. If it doesn't stick, the rest of your model is not going to come out. As I said though, you can see here a better idea of what I mean by layers. It's breaking it down into each layer, and then each layer has a machine path that it tells the head of the printer to run. So as it's printing my brim here, this is the path it's putting into G-code to send to the machine. And you can see it just kind of goes around and fills out the dots and builds the model up from there. So we'll go ahead and save this and jump over to the printer. Alright, so I'm getting ready to print my first model. I have my spool of filament here, and I'm going to go ahead and just clip the end of it at about a 45-degree angle there. Then there is a little guide hole in the back of the extruder, and I'm going to feed it in there and depress the lever to give me enough room to slide through into the Bowden tube. And you're going to hold the lever down, feed as much filament into the Bowden tube as you can. You'll start to feel resistance once it reaches the end, and you are loaded and ready to go. And now that I've got my file saved, I'm going to head over to my printer here. As you can see, I have my SD card here. This is a full-size SD card. It's going to go in this slot right here. Then if you follow me on over to the screen here, we are going to go down to print from SD. We're going to print the Tarantula Pro filament holder. Alright, so as you can see, it is starting to lay down my brim here. I have sped up the process because we are going to wait and wait and wait some more. Now, this is not a super fast process. This is going to be a 2-hour print, which is not bad for a part of this size. My TiVo Tarantula here is actually very fast. Patience, they say, is a virtue, and when it comes to 3D printing, it is definitely something you're going to need to learn. If you are impatient, there is a possibility not only will you wreck your model, but in trying to do things too quickly, you can also cause damage to the machine. Now, it may seem like it takes forever, but we'll get there, and when we do, we'll have a nice model that we can do whatever it is purposed for with. Alright, so here we have our finished model. I'm going to go ahead and gently remove it from the build plate. I have a magnetic bed, so I can simply lift my magnet up, and I'll show you that now. Then peel it away from the bottom of the brim and let it slap back down there. And here you see I have the completed spool holder. Now, the last step to this process is the post-processing and finishing process. There are a couple of steps to that process. And I'm going to get out my clippers, and I'm basically going to clip into the brim, and then I'm going to press and peel it downward and away from the model. This is the easiest way to remove it. You need to be careful when removing brims, and supports and things like that, because sometimes they can have sharp edges, so it is easy to cut yourself and things of that nature if you're not paying attention. If you're careful, you shouldn't have any problems, but there's no reason to run through it all hastily. I am going to speed this up on the camera here though, and this is called deburring, where I'm taking the jagged edges off of the corner. There are special tools they make for this. I highly recommend checking out Chuck Hellebuck's Filament Friday tool, which is a specialized tool for removing burrs like that. That was some support I clipped off there. I found those instructions in the pictures that came with the download of the model, and that is basically it for the first step. I've cleaned up most of the corners, do a little more deburring, and just kind of scraping, and then we're going to move on to the second part, which is a light sanding. Now I have a medium grade sandpaper here, and I'm simply going to rub it in circles and sand until I have a fairly smooth surface. Now, the reason I'm using white here is because it's a printer's trick that white filament really easily hides layer lines. So this model is not quite as nice as it looks. I will tell you, white does hide the layer lines really easily, but depending on what kind of printer you have, sometimes white can be a little difficult to print with, but came out looking all right. That's basically it for the process of making something with a 3D printer, and now I'm going to use my handy V-slot locking nut to mount the spool and move the spool up to where it needs to be so it will flow easily into the extruder without causing any jams or problems or anything like that. So this isn't really part of the printing process, but I guess I'll show you how to do it anyway. Basically, I slid the lock nut in there, and then I realized it would be easier to pre-fasten it. So we're going to take the time to put the bolt through here. As you can see, it just slides in this little hole here. Then I am going to fasten the locking nut to that. I'm also going to drop it after I think I have it fastened, but let me show you how you want to align a nut like this if you're trying to put it into a slot while it's already on the bolt. You want it to be horizontal with the bar so the thin part slides into the V slot. And there it went. I dropped it right in the slot. This is basically the gist of it. So it's a 4-step process. You have to obtain a model, you have to slice that model, you have to print that model, and then you have to clean that model up. All in all, this process for making this spool holder, it was a 2-hour print. It probably took me about 3 to 3.5 hours from start to finish. And I condensed that down into this video, just about 20 minutes, which isn't too bad. So I hope this has been helpful for you. I'm going to test out my new spool holder by running some prints. And don't forget to hit that like button and smash the subscribe button, because we have lots of videos coming out in the future about learning 3D printing, and there's a ton of stuff on my page already. So feel free to pop over there and check that out as well. As always, this channel is brought to you by these fine Patreon supporters. If you'd like to support the channel on Patreon, head over to www.patreon.com/Technivorous. Alright guys, that's going to be the end of this video. As always, thank you. I'll put a video up right here that you can check out for more of our stuff. And if you're still here and you haven't already, why don't you click right here and subscribe to the channel.